please do take some time to play with us, because if this is the first time you're doing this, some things might not be clear. And the best way to really make sense of this is to type code, run it, and see the effect of what you type by running your program. So let's do this a couple of times. We're going to do std endl after the statement for number 2. We're going to do stdcout 3, and we're going to do stdendl to really show the problem again. We're going to take out stdendl on the number 2 line. We are going to build. The build is going to be successful. We're going to click in the terminal, hit enter, hit the up arrow button, run the program again, and you're going to see it's saying number 1. It's going on the new line, printing number 2, but we're not jumping to the new line from number 2. So number 2 and number 3 are going to be cramped on one line. That's what we see here. You can solve this again by putting in a new line after number 2. Let's do std endl here, and this should solve the problem. Again, let's build. We're going to run our build task. The build is going to be successful. We're going to hit the up arrow to run the program. If we run it, it's going to say number 1, number 2, and number 3, and this is really good. Now it should be clear that statements in the main function are run in order from top to bottom, and that the program is going to end when it hits the end of this curly brace that includes our function. We're going to have a chance to learn more about functions in detail later in the course, but we are just getting started and we need to start somewhere. So that's why we're doing this main function thing here. Another thing you can do is return from the main function, and in many examples you will see people do return 0, something like this. And this is a way for the main function to send the message to the operating system if it's finished successfully or if there was some kind of problem. We're not going to go into any more details about the main function because that's really too much for now. We are just getting started. We are trying to get a feel of how C++ works. The main message here is really that you should be able to print things to the console using stdcout. You should be able to print a new line after your message using stdendl. This stdcout and stdendl thing come from the IOStream library that we are including here. If we don't include this library, we're going to have problems because our C++ program is not going to know where they are coming from. So we should really put that in if we want to use these features. And we can return from a function to let the system know, the operating system, if the program finished up successfully or if there was some kind of problem. And again, this project is using the template we've done before. And this is really all we set out to do in this lecture. Trying to make sense of the main function in C++. To really practice this thing, I would challenge you to write a C++ program just like this that is going to print your name 10 times. Try to do that. And if you have a problem, please do ask me and I will do the best I can to help you out. This is really all we set out to do in this lecture. I hope you found it interesting. We're going to stop here in this lecture, and then we're going to start and learn about comments in C++. Go ahead and reach out here and meet me there. In this lecture, we're going to learn about comments in C++. Comments are a way to put some messages in your C++ code that are really meant to be read by humans. And one way we have to do comments in C++ is through this // when we head here. This is going to comment out the line, so the compiler is really not going to care about it. It's going to think that it is something that is meant for the developer to see. So this is a one-line comment, and this is how you do it in C++. You can also comment out code in your C++ code, and this is something that comes in quite handy many times. You put your comment in a \* and a */ like this. This is going to comment things out in your code, and the compiler is really not going to care about this. Let's hop over to Visual Studio Code and actually play with this. So here we are in the folder that is going to contain our code. The first thing I'm going to do is go to the template project. I'm going to copy my files. and I'm going to go up again, and we're going to be learning about comments. So I'm going to put this in the folder on comments. I am going to close whatever folder we have opened in Visual Studio Code, and I'm going to browse to the location where my project on comments is. My project is in this folder that is named 33 comments. I'm going to open the folder, and if I open the main CPP file, I'm going to find the starter project. We're going to remove this const eval thing because we're really not ready to understand this yet. It was in here to help us test that our compilers support C++ fully. So we're going to remove this, and we're going to put in a message that says, hello world. You already know how to do that.
Let me see.
Many times. You put your comment, let's copy my files, your code, and actually play with this. So here we are in the folder that is going to contain our code. The first thing I'm going to do is go through the template project. I'm going to copy my files, and I'm going to go up again, and we're going to be learning about comments. So I'm going to put this in the folder on comments. I am going to close whatever folder we have opened in Visual Studio Code, and I'm going to browse to the location where my project on comments is. My project is in this folder that is named 33 comments. I'm going to open the folder, and if I open the main CPP file, I'm going to find the starter project. I'm going to remove this const eval because we're really not ready to understand this yet. It was in here.
What is it called? VS Studio, VS Projects.
So we're going to remove that.
Yeah.
And we're going to put in a message that says, hello world. You already know how to do that from the last lecture. So we're going to say stdc out, hello world, and we're going to say stdendl, and don't forget this semicolon at the end. If you do, you're going to have problems. So make sure your code looks like that.
Yeah, hold on, I'm just curious.
Code, and I'm going to browse about comments, container code. The first thing I'm going to comments, I am going to close whatever folder we have open in Visual Studio Code, and I'm going to browse the location where my project on comments is. My project is in this folder that is named 33 comments. I'm going to open the folder, and if I open the main CPP file, I'm going to find the starter project. We're going to remove this const eval thing because we're really not ready to understand this yet. It was in here to help us test that our compilers support C++ fully. So we're going to remove this, and we're going to put in a message that says, hello world. You already know how to do that from the last lecture. So we're going to say stdc out.
It's just you deleted all of that.
Because we're really not ready to understand this yet. It was in here to help us test that our compilers support C++. So we're going to remove this, and we're going to put in a message that says, hello world. You already know how to do that from the last lecture. So we're going to say stdc out, hello world, and we're going to say stdendl, and don't forget this semicolon at the end. If you do, you're going to have problems. So make sure your code looks like this. Try to build it, make sure it's working fine. This is going to run the GCC test world. You can click on the terminal here, and it's going to close the terminal. And we can open a new terminal here if we want. If we do dirt, we're going to find our rooster program inside. We can run it, and it's going to say hello world. We already know to do this from the last lecture, and in this one, we are going to be learning about. So you want to be a software engineer? Go to boot.net, make a free account. The first thing you can do is use // So let's do that. And let's put some message here. This brings in the IO stream writer. This is a nice method that is going to give some more information about this statement to whoever might be reading this program. And this is called a one-line. You can really put this wherever you want in your C++ file. You can go in the main function, for example, and say this is going to print hello world, the console, or the terminal. We can really put this anywhere. We can even put it after the return statement here, and really put in whatever piece of information we think is going to make sense to whoever is going to be reading our program. Okay, this is how you do a one-line comment. You can also do comments across different lines. And the way you do that, you put that in the /* and go down and say star slash like this, and whatever is going to be in the middle here is going to be a comment. This is usually
Excuse
called
me.
a block comment. You can put in whatever you want. So if you have a piece of text that you would like to use as a comment in your program, this is one way you can do this. One thing you should know though is that you cannot nest these things. But before we do that, let's try to build a program to really show that there is no problem.
Just so I can see.
One.
Fun.
Thing you should know though is that you cannot net these things. But before we do that, let's try to build a program to really show that there is no problem if we have these comments in. The build is successful, and if we click on this terminal and hit enter and hit clear to clear things out in the terminal, we can try to run our booster program, and it's going to say hello world. You see that all these green lines, which are comments, are really not affecting the program. All the compiler is going to care about is this include button. It's going to care about the main function here. It's going
Hold
to
on.
really show that there is no
Yeah,
problem.
no, I need
If we have these
to.
comments in, the build is successful. And if we click on this terminal and hit enter and hit clear to clear things out in the terminal, we can try to run our booster program.
There we go.
And it's going to say hello world. You see that all these green lines, which are comments, are really not affecting the program. All the compiler is going to care about is this include.
There we are.
It's going to care about the main function here. It's going to ignore these green things. It's going to be like these green lines that are comments are not in there. This is the effect comments have in your program. And we're going to be using this a lot in this course. One thing you should know though is that you cannot nest these block comments. So if you try to do something like this and say this is one comment and come again and say this is another comment, you see that we have problems already. Nesting is not allowed. You're going to get a compiler error, and we're going to learn more about these errors in the next. But don't do this. Don't nest these block comments. If you do that, you're going to get some confusing errors, and this is going to be the cause for that. So don't nest your block comments. It's going to give you headaches. Okay, this is really all we set out to do in this lecture, learning about comments in C++. You can do one-line comments on a single line like this. You can do block comments to comment out a block of text. You can't nest your block comments because that's going to give you a lot of problems. You don't want that. And really use comments wisely and don't overdo it because it's going to turn your program into a novel. And I don't think people want that. So use these video when you need it to give some more information about your code and don't overdo it. We are going to stop here in this lecture. In the next one, we're going to learn about different kinds of errors and warnings you can see in your C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about errors and warnings in your C++ programs. There are three kinds of errors, warnings you can get. You can get compile time errors, you can get runtime errors, and you can get warnings. But what is really meant by these things? Remember, the ultimate goal of every developer or every C++ developer in our case here is to be able to generate a binary executable file from the C++ code. And we have to run the compiler to be able to do that. And one thing we should know is that there is a set of requirements that the compiler enforces on our code for it to be able to complete
that real quick.
Don't overdo this. We are going to stop here in this lecture. The next one we're going to learn about different kinds of errors and warnings you can see in your C++ program. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about errors and warnings in your C++ programs.
Let's see. Let me move you. Mm. Excuse me. Grab you. Okay. Paste you. Okay, I think I got it. I guess I could have grabbed all of you. Let's do that. Copy. Mm, Move you down. Now let's go up. Perfect. Um, shoot.
Go ahead and finish up here. Meet me there. In this lecture, we're going to learn about errors and warnings in your C++ programs. There are three kinds of errors.
Hold on. How do I edit? That's required. There we go. No, not what I wanted. Whoops. Okay.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44.
Okay. No, I didn't even finish. Okay. Where's the site? There you are.
can get errors, you can get runtime errors, and you can get warnings. But what is really meant by these things? Remember, the ultimate goal of every developer or every C++ developer in our case here is to be able to generate a binary executable file from the C++ code. And we have to run the code through the compiler to be able to do that. And one thing you should know is that there is a set of requirements that the compiler enforces on our code for it to be able to compile.
Hmm.
Hey, honey, I gotta go.
Have a good day, Father.
Love you, son.
Love you.
And those requirements are the rules really that we have to follow in our C++ program. And if we break those rules, we're going to get problems. And these problems are going to come in the form of compile time errors, runtime errors, or warnings. Let's look at compile time errors in detail. Here we have a simple C++ program that has few problems. We have forgotten to put the semicolon at the end of our stdc out statement here, and the compiler is going to freak out because of this. If you compile this program, you're going to get a bunch of errors, and the IDE is going to show us this problem. Some IDEs are going to give you different errors. For example, here I was using CodeFlight, and it was saying error expected semicolon before return or something like this. So this is a compiler.
Hi, Bob. What are you doing? Wanna come visit me? Here. Well. There you go. Okay.
And if you have this kind of errors, your program is not going to compile, compilation is going to fail, you're going to get this error and you're not going to get your binary executable. And when you have this, you basically have to go back and fix this problem, compile again, and when you get rid of these problems, the compilation is going to succeed. This is what a compile time error does. Another thing you can have is a runtime error. This is not going to cause a compile time error. The compilation is going to succeed.
Hold on.
When you run the
So that was a
go back and fix what you have. Yes. And the IDE is going to throw us this problem. Some IDEs are going to give you different errors. For example, here I was using code light and it was saying error expected semicolon before return or something like this. So this is a compiler error. And if you have this kind of errors, your program is not going to compile. Compilation is going to fail. You're going to get this error and you're not going to get your binary executable. And when you have this, you basically have to go back and fix this problem, compile again, and when you get rid of these problems, the compilation is going to succeed. This is what a compile time error does.
compile time error. Okay. Compile time error.
Thing you can have is a runtime error. This is not going to cause a compile time error. The compilation is going to succeed, but when you run the program, it's not going to do what you intended it to do in the first place. For example, you may want it to print green on some user interface. It's going to print gray or whatever. It's really not going to do what you want. So it's a logical error that you have in your program, and you have to fix it to get rid of this. And another thing you should know is that sometimes these runtime errors can cause your program to fail and terminate immediately, and we say that the program has crashed.
Okay.
There's all that we fight for, and all that we fight against.
These darn ads.
The line where our nation's future's won. We are Marines. We were made for this.
That's great. There we go. Okay, great. Okay. Compile time error.
is sometimes you can have this problem, compile again, and when you get rid of these problems, the compilation is going to succeed. This is what a compile time error is. Another thing you can have is a runtime error. This is not going to cause a compile time error. The compilation is going to succeed, but when you run the program, it's not going to do what you intended it to do in the first place. Right? So you may want it to break. The compilation is going to succeed, but when you run the program, it's not going to do what you intended it. To do in the first place. For example, you may want it to print green on some user interface. It's going to print gray or whatever. It's really not going to do what you want. So it's a logical error that you have in your program, and you have to fix it to get rid of this. And another thing you should know is that sometimes these runtime errors can cause your program to fail and terminate immediately. We say that the program has crashed. We're going to see an example of this in a minute. The last kind of problem you can have in your program is a warning. This is the is not serious enough for the compiler to halt your compilation. Compilation is going to succeed, but this is basically the compiler telling you you are doing something that has some problems and you should really fix it before. It becomes a serious problem. So that's going to be a warning. For example, here you see some compilers can warn you when you divide stuff by zero, and we need to see how this works. The main message in this lecture is that you may have problems in your program, and that they are going to come in three forms. Some are going to be compile time errors, some are going to be runtime errors, some are going to be warnings. We are going to hop over to Visual Studio Code and actually play with this.
So many edits.
Okay, here I am. In the Visual Studio Code, the first thing I'm going to do is to set up the template project we're going to be using in our project here. The project is going to live in this folder, errors and warnings. I am going to copy over the files, and I am going to go in the current project we're going to be working on, and I am going to open this folder in Visual Studio Code. I am going to go to File, Close Folder. I am going to close this one, and I am going to open our new project. I am going to browse to it. The project is this one.
I'm curious if I can slightly organize that a little bit. It is. It's right there, but let me just see if I can adjust that without messing up anything. Which I don't know if that'll be possible, but let's just name it how it is. Yeah, I gotta close that first. Let's see if I can just do this. What the hell? Oh, because I was holding shift. Okay. Okay, so moving this in here. I don't know if that'll mess up anything, but me actually rename this without the period like he has, because I would ideally like it to be, yeah, right there. Okay. So he great. And then comments. Yeah, that's how you spell comments, first of all. There we go. Great. So hopefully that didn't mess up anything. I guess let me just see to make sure. Maybe. Maybe did. Not sure. Still has you. If I wanted to run you, would that still be possible? MSVC. Shit. Not ideal. Let's see. Did that mess up? Ideally, you should be. Yeah, okay, that did mess that up. Okay, let me fix that real quick. Okay. Let me get the path. It's this right here. Plus 20 template. Okay, great. Cool. Let's fix you up. Should be. Is that not how it is? No. How was it? I forgot. So we're at 2 hours and 6 minutes.
Full Sail University is where the next generation of creators are learning to build the future.
That's great.
What I am going to do is really trust this. So
Gotta scrub through
so
this. Yeah. Well, I wonder if I need to fix all of that too. Not you.
Major W compiler, and I would recommend reading up on this entire thing.
How much shiz to deal with.
But of course, you are free to C++ programs. So once you have this, you can click save here, and this is going to say,
Yeah, so that's all accurate.
Close this. And I'm going to bring my terminal by going to view and a terminal here. This is going to bring content. And I am going to say the name of the file I want to remove. I am going to say main.exe. And if I hit enter, notice what is going to happen. The file is going to go. I don't see it.
Yeah, I know.
Terminal plus. So this is what.
Let me get. Oh, here we go.
For the project that I just set up.
Yeah.
So I'm going to say CD and this is account I just.
Oh, I thought. I mean, that's what I did. Should be what I'm doing. There we go. Yeah, so should be that. Okay. Why? Am I missing something here? This should be the path. ED. Wait, hold on. What? Tarnation. No, that doesn't. Okay, let me see his.
The project here. So I can grab the location from my Visual Studio Code project that I just set up. I am going to come back to my PowerShell window, which steps we have here. This little guy here. We also want the ability to use the converter from Microsoft. But to have access to that, we will have those the Visual Studio Code instance we have here.
Mm-hmm.
And we're going to come back to our project. Let's see if I can find it here. So we're going to go to the location where we have our
You're
project.
working.
And then we're going to change to the location of the project here. So I can grab the location.
Mm-hmm. Project. Hmm. This is very interesting. Yeah. Okay, so that is all in now. Let's just, I don't know, just save as. I'm kind of, yeah, let's just do that. I mean, I don't know. I would guess you would run with other stuff, right? So I use GCC, yeah, that works fine. Okay. Okay, so you seem fine there. Guess let me just do this again. So that should be that one, but let's just make sure. C++ 20 template. Looks good. Copy. Alright. Well, let's ask, I guess. Is that the problem? Well, we can see, I guess. So, I don't even have the thing. Hold on. Oh, it's because I know why. Okay. Huh. Okay, so it is really that space that probably messed it up. Okay. Well, should work now. Need source file. So now, let's see here. Let's get the terminal. Shit. Oh, I know. It's because I'm silly. Space dot code. There we go. Okay, so now terminal. There we go. Perfecto. I don't even know if I miss, like, if I needed to do that, but oh well. There we go. Here, let us. And close you, close. Well, I don't know if I would. I don't know.
You see that? Put it in mode where it knows.
Oh wait, let me get back to.
Ready and say CL.
Gotta go raw.
It's enough for the compiler to halt your compilation. Compilation is going to succeed, but this is basically the compiler telling you you are doing something that has some problems, and you should really fix it before it becomes a serious problem. So that's going to be a warning. For example, here you see some compilers can warn you when you define stuff by zero, and we're going to see how this works. The main message in this lecture is that you may have problems in your program, and they are going to come in three forms. Some are going to be compile time errors, some are going to be runtime errors, some are going to be warnings. We are going to hop over to Visual Studio Code and actually play with this. Okay, here I am in Visual Studio Code. The first thing I'm going to do is to set up the template project we're going to be using in our project. Here, the project is going to live in this folder, errors. I am going to copy over the files, and I am going to go in the current project we're going to be working on, and I am going to open this folder in Visual Studio Code. I am going to go to File, Close Folder.
Let me close that real quick though.
And I am going to open our new project. I am going to browse.
Why isn't that? Does it just do that now? Is that like a thing?
And select folder, and it is going to open up in Visual Studio Code. I am going to close this welcome screen and open our main CPP file. We're going to get rid of this const eval thing. This is the C++ 20 test thing we had in. We don't really need it now. We're going to get there in due time. What we want to see is compile time errors.
Right. Hold on, Bob. Hold on. Wow, you're going so quick.
The project is going to live in this folder, errors and warnings. I am going to copy over the files, and I am going to go in the current project we're going to be working on, and I am going to open this folder in Visual Studio Code. I am going to go to File, Close Folder. I am going to close this one, and I am going to open our new project. I am going to browse to it. The project is this one. I am going to select it and select folder, and it is going to open up in Visual Studio Code. I am going to close this welcome screen and open our main CPP file. We're going to get rid of this const eval thing. This is the C++ 20 test thing we had in. We don't really need it now. We're going to get there in due time. What we want to see is compile time errors. We're going to put in our stdc out statement, hello world, as we usually do. We're going to end this std and we're going to remove the semicolon purpose. And if we try to compile a program like this, we're going to get a compile time error. This is what we want to see. So let's try and build our program. We're going to run
because it's no
ECC, and you see that the build failed. We're going to get a bunch of errors in our terminal. It's going to say in function int main expected a semicolon before return.
Okay, hold on. You're a little too quick for me, Bob. There we go. Okay. So now, so we have a couple errors already. Hello world, you're wanting that, and then no quotation, and then return 0. I think there's something there that I'm forgetting. Maybe no, I think it's just the quotation actually. At that point, so are you running build task? I'm assuming.
The STD and and we're going to remove the semicolon from perfect task to build with compile our program like this. We're going to get a compile time error. This is what we want to see. So let's try and build our program. We're going to run the task to build with GCC, and you see that the build fails. We're going to get a bunch of errors in our terminal. Going to say in function int main expected a semicolon before return. It's going to try its best to tell you what the problem is, but sometimes these errors can be really confusing. In this case, it is really easy because we introduced this error on purpose. So we're going to fix it in a minute. But before we do that, I want you to see these problems tab. It is where the problems are going to show up in Visual.
So you have one problem.
So you should see a problem in here or through the terminal. Okay, one thing you should know is that when you have a compiler,
interesting. It's just saying before return, I guess.
And you're not going to have your binary file, which is what we really want. So to fix this problem, we're going to put in our semicolon here. We're going to build again. We're going to go to terminal, run task. We're going to build with GCC. And this time you're going to see that compilation is going to succeed and we have our program. We can run it through the terminal here. So we're going to click, the terminal is going to go away, but we can open our own. And if we do dir, we're going to see our files in here and we can run our program. We can say booster, and if we run, we're going to have hello world. So I hope this really makes it very clear what a compile time error is. So this is one kind of error you can get. The other one is a runtime error. And this comes in the form of things that don't work as you really expected. So let's say we are trying to do some computation in our program. We try to take 7 and divide this by 0, for example. And this is the statement that is allowed in C++. So
you need 2 slashes.
And see what we get. Because this is a common scenario where we have runtime errors. We're going to run the task build with GCC. Okay, if we do this, you see
no, it's because it's 0. Oh, yeah.
We didn't get a compile.
And 2 slashes is a comment.
So let me build a e-commerce store preloaded with 20 handpicked products.
So to really prove this, I'm going to go back in our directory. I'm going to do dir. You're going to see that booster is there. I'm going to remove it. I'm going to say booster.exe. This is how we remove stuff from the command line. When I do this and do dir again, the executable file should be gone. So let's try and build with this statement in, and you're going to see that we get a warning and not a compile time error like we had. So we're going to go to terminal, run task. We're going to build with GCC, and you're going to see that we're going to have our executable here, but we had a warning, and it's saying that division by 0 was detected in our program, and it is a recipe for disaster. So why is it a disaster? Let's try and run this program. So we're going to dir to prove it's here, and we're going to run it. If we run it, it's going to say hello world, and it's going to end. Let's try and actually use our own terminal to see if we have a better chance of seeing the problem here. So I'm going to reveal in Explorer by clicking on main CPP, and I am going to try and open the terminal window PowerShell.
I see. It's because I misspelled.
This shouldn't be new to you by now.
There we go. So it still compiles.
Here, and we're going to try and
But with warnings.
So it's not really giving us a runtime error here because we're not capturing this or trying to use the result of this division here. We're just doing the division, which is a problem. So let's try and capture this. We haven't learned about variables yet, but what we're going to do now is do int value, and we're going to assign the result of this division to this value. And let's try printing the result of dividing it up 0. So we're going to do stdc out, and we're going to say value, and this is how you can print a value out on the console. Okay, now that we have this in, let's try it in world. We're going to run test and
Hold on,
world
whoa,
with
chief. Holy moly. Alright, see out value. Wait. No. Okay. Did I do everything there correct? Looks like yeah. And then
and this is how you can print a value out on the console. Okay, now that we have this in, let's try it in world. We're going to run test in world with GCC. We're going to get the same warning, but if we try to run the
yeah. Same warning, okay.
we're not going to get what we expect. Let's run booster exe. We expect it to say hello world and print the value, but you see that it's really struggling to print the value and it gave up and ended immediately. So
It did?
exe and world with GCC, we're going to
Oh,
get
it
the
did.
same warning, but
Maybe?
if you try to run the program, you're not going to get what we expect. Let's run booster exe. We expect it to say hello world and print the value. You see that it's really struggling to print the value and it gave up and
Didn't
ended
print anything
immediately.
after.
So this is one example of the runtime error that you can face in your program. There are many other kinds that we're going to see as we progress in the course. Here, we are just trying to raise your awareness to these problems so that you can know how to fix them when they come up. Okay, so this is all I can share with you now about runtime errors. We also had a chance to see that this is also going to give you a warning. And a Visual Studio Code here is also helping out, telling us that you may have a problem. It's turning the main CPP file yellow, and it's saying that there is one problem in this file. And if you go here, you're going to see that we have a warning. Okay, so this is one way you have to see this. So this is not recommended to do, so we're going to comment this out. Okay, this is really all I have to share in this lecture. We had a chance to look at compile time errors. We also had a chance to look at warnings and runtime errors using this example. If you get the warning, it is a message the compiler is giving you that you should really look it up and fix the problem before it becomes more serious. Compile time errors are going to cause your compilation to fail, and that's a really good thing because the compiler is going to stop you from generating a binary that doesn't really do what you expect it to do. So that's a good thing. But sometimes the compiler won't give you a compiler error, and we have to just run into a runtime error, and that's really bad. So be careful about these things. And when you have problems, Visual Studio Code is going to show you the problem in Terminal or in this Problems tab, and you're going to be able to fix that. We're going to stop here in this lecture. In the next one, we're going to learn a little more about statements and functions. Go ahead and finish up here. Meet me there. In this lecture, we're going to learn about a little more about statements and functions in C++. A statement is a basic unit of computation in C++. You can say that
Oh,
in
it really doesn't bother me, so. Okay. Whatever you want to do, Mom. Computation.
your CPU can execute a new program. C++ program is a collection of statements, so you're going to have a bunch of statements that are organized in a certain way to achieve whatever it is you want. And statements in C++ must end with a semicolon. We saw in the last lecture that not putting that semicolon is going to result in a compile time error. Here is a basic sample C++ program that we're going to use to learn about statements. In the main function here, we have two variables declared. We haven't really learned about variables, but they are a way to store data in your program. And here we are storing two decimal numbers. One is called first number, the second is called second number. We can do something with these variables that we have in our program. For example, we can add them to have another variable in our program, and we can print that. So you see here we are saying stdc out, the sum of two numbers is sum. So this is going to print 21 because it's going to add 12 and 9. And the result of that is going to be displayed on the terminal if we run this program. What I really want you to notice is that this int first number equals 12 thing is a statement in C++. So it must end with a semicolon. The line here with second number is also a statement, so it must end with a semicolon. Every single line we have here in the main function is really a statement, and it must end with a semicolon. If we don't put the semicolon in place, we're going to get a compiler error. Okay, one of the things that is really important to keep in mind is that statements are executed in order in your program, and the order is from top to bottom. If we go back to our program,
Interesting. Okay, yeah, that makes sense. I'm like, what? I wonder why it keeps doing that. Because I already changed it using single.exe and stuff. Yeah, I don't know. Every time I open something, it keeps... I don't know, whatever.
First to keep in mind is that statements are executed in order in your program, and the order is from top to bottom. If we go back to our program here, so the first statement is the one with first number here. 12 is going to be stored in memory when this statement is executed by your computer. And we're going to go to the second statement with second number, and we're going to keep going until we hit the end of the main function, and the return statement is going to execute. And when the main function returns or terminates, you're going to get the return value sent to your operating system, and it's going to know if your program ended successfully or with a problem. And the operating system is going to know what to do with that information. Execution keeps going until we hit the end of the program, or if there is any other condition causing for the program to terminate. And we're going to have more details about these things later. I just want you to know that the statements are executed in order in your main function.
Can I help you, sir? Here's the bill from the dealership where I got mine. I'd like you to beat it with a better deal on one of these. Well, not how it works. Guess you're not school for us.
Bring in your AT&T or T-Mobile bill today for a better deal.
Another concept I really want you to have an idea about is the concept of functions. A function is really like a machine. You give it input and it's going to give you output. If we look at the operation here to add first number to second number, we can consider first number and second number as input to the function, and sum is the output. We can visualize that like this. So we have a first number and a second number, pass that into our machine, which is really a function, and we're going to get the result of this function in a return value or something that we get out of the function as our result. C++ has a special syntax we use to define functions. This is our function to add numbers. On the left, we have an integer, which is code name for a whole number in C++. It's a number without decimal points, and it's a whole number. After that,
Okay.
On the left, we have an integer, which is code name for a whole number in C++. It's a number without decimal points, and it's a whole number. After that, we have the name of the function, and we can name it whatever we want. And after that, we're going to have the list of parameters that we can pass to the function. And this is going to work as the input to the function. After you do that, you're going to have a pair of curly braces. One is here, the other is here to the end. And with this input, and we can name it whatever we want. And after that, we're going to have the list of parameters that we can pass to the function. And this is going to work as the input to the function. After you do that, you're going to have a pair of curly braces. One is here, the other is here to the end. And within those curly braces,
parameters.
it's going to be the body of the function. Inside the function, you see that we are declaring a variable which is called sum, and we are storing the sum of first number and second number in this variable, and we are making this function return the sum as the result. And we're going to be able to capture it if we call this function in a function like main. We're going to see how this works in a minute. A function must be defined before it's used. Can't really call a function we haven't defined first in your C++ program. And here is a slightly complete program to really put all these ideas. We have our function to add numbers. It takes two numbers, first number and second number. It's going to add them up and store the result. And we're going to return the sum to be used by whoever calls this function. And if you look in our main program, we have a statement here. We're going to store the result of add numbers and the sum variable, and we pass first number and second number in the function, and we're going to have that result stored in. Here, we also call the function with direct numbers. You see that we pass in 34 and 7, and we're going to print out the result. This is the basic idea I want you to have about functions. They are reusable pieces of code that group together a bunch of statements to do whatever it is we want to do in that function.
Legacy code brains don't touch.
One benefit about functions is that we can reuse the code. If you look here, we are calling this function multiple times without really rewriting the statements that are inside the function. I know some of these concepts might be scripted to you right now. We are going to go to Visual Studio Code and try this in code, and you're going to see exactly how this works. Okay, here we are in our folder where we are storing our projects. I am going to grab the code from the template project. I am going to put that in the current project, which is statements and functions. I'm going to paste that in here, and I am going to open this up in Visual Studio Code. I am going to close the project we have right now, and I am going to open our new project. Let's browse to its location. I am going to open the project on statements and functions. Let's open this folder in Visual Studio Code, and we're going to have our starter project. I am going to take out whatever we have in the main function and take out this function value when we don't really need it. And we are going to try to define two variables using two statements. We are going to say int first number, and we're going to put in the value, let's say 3, and we have to remember to end this with a semicolon. So this makes our statement. We can encode this in a comment to make this pretty clear. We're going to also define a second variable. So we're going to say int to mean that it is a whole number. It doesn't have decimal points like 2.5. It is a whole number, like 1 or 7 or 10. So we're going to say second number. Can give it a name, and let's put in a 7. We're going to store these values in our program, and we can print these values out. Let's print them out first. So we're going to say stdc out. You already know how to do that, and we can say first number, and we can change these output statements and say the first number is first number. You can do that stdendl, and you can notice that Visual Studio Code is really helping out in auto-completing things we have in our program. Let's print the second number to really practice this. So if we do std, we're going to see that it's going to give us a bunch of options we can choose from. If you want, you can scroll through this with your mouse, or you can just type whatever you want to type. So I am going to do cout, and it's going to try and help out. If I really want, I can come on cout here and click on it, and it's going to be auto-completed, which is pretty cool. So we're going to say second number, and we're going to say second number here, and it's going to auto-complete for us, endl, and we can try and compile this program. Before we do, I want you to guess what we're going to get when we run this program. Give it a guess. We are then going to go to terminal, run task.
Wait, hold on. I have an error. What's wrong? Oh, I see. There we go. Great. It's gonna print both numbers. 3 and 7. Yeah. Oh, and the string. Oops. Wait. There we go. Is that gonna be updated, or do I have to rerun it? Yeah, rerun it. Okay. There we go.
GCC deploy is going to be successful. Going to open this in our terminal. The terminal goes away, no problem. Going to open it again, and we are going to go in our folder, do dir, and you're going to see that we have booster.exe, our program. We can run it, and it's going to say first number 3 and second number 7. This is what we have stored in this variable. And the benefit of storing your data in variables is that you can change the variables and let the rest of your program really do the same things and pick up the data that you have in those variables. For example, we can put 13 in the first number, and if we load again, this number is going to be picked up by this code, and we didn't need to go in and manually change data in these stdc out statements here. Let's load so that we can see this, and we can close this by clicking, and if we run rooster again, it's going to say 13 and 7. Play with it a couple of times until you really feel confident. And
Shoot.
if you have any problem, don't hesitate to ask me. I am going to do the best I can to help you out. Now that we have these numbers stored in our program, we can add them up. Let's say int sum. We're going to declare another variable, and we're going to say it's equal to first number plus second number. And we're going to end this with a semicolon. And we're going to print the sum out. Let's do stdc out. And we're going to say the sum is sum. We're going to print our variable here, and we're going to print a new line character with stdendl. We're going to build our program so that our changes are reflected in our binary here. So we're going to go to terminal, run task, build with GCC. The build is going to be successful. We're going to press any key. We are going to click here in the terminal, and we're going to hit enter and run booster again. And we should see the sum, and you see it says the sum is 20, which is what we expect. Now we are doing the sum here.
Grand, you got 20? Yeah, okay, cool.
But it would really be better if we're not doing the sum in the main function here. What if we actually took this code and wrapped it in a function that we could reuse whenever we want? We have seen how we can declare a function. So let's do that. We're going to follow the same structure we saw in the slides earlier. So we're going to say int, this is going to be the return value or what we get out of the function. Then we're going to put in the name of the function. We're going to say add numbers, and we're going to pass the parameters. The parameters can really have any name you want, but you have to specify the type of the parameter first. So the parameters are also going to be whole numbers like 1, 5, 7, or whatever you want. And we're going to say first param, and the second is going to also be a whole number, an integer, and it's going to be second param. Okay, after we do this, we're going to specify the body of the function, which is going to be between these curly braces. I am going to jump to the next line so that this is really easy to see. So I am going to define our sum variable inside the function. It's going to be a whole number, and I can call it whatever I want. So let's call it result, because it's going to be the result of this function, and the result is going to be the sum of first param and second param. Okay, I hope this makes sense. And we're going to end this with a semicolon, because every statement in C++ has to end with a semicolon. After we have the result,
Yeah, cool.
we need to give it back to whoever called this function, and we're going to do that with a return statement. And we're going to return the result to whoever might have called this function. Now that we have the function, we can actually use it. We're going to go back in
Hold
our
on.
main
What's
function,
this?
and
In what? What? I have int. Oh, I don't have int. There we go.
the result to whoever might have called this function. Now that we have the function, we can actually use it. We're going to go back in our main function, and what we're going to do is to reuse the sum variable and store in whatever is returned from our function. The syntax for that is going to be sum, and we're going to say equals, and we're going to say add numbers, and we can pass in whatever two numbers that we want to add up. Let's pass in 25 and 7, for example. We would expect this to give us 32. So if we print the sum again, we can just copy this statement that prints the sum and reuse it here. Let's align this a little bit. And I want you to take a guess at what we are going to get from this program right now. We have these two numbers, we are adding them up. If we get here, this should print the first number, which is going to be a 13. So here we expect to get 13. And by the time we get the second number statement, we are going to print the second number. It's going to be 7. If we get here, we're going to print whatever is stored in sum. And in sum, we have the sum of first number and second number. So this should print 20. Right? And here we are doing another sum of two numbers, but we are using a predefined function that we have here before the main function, because you have to define the function before you use it. Okay, if we add 25 and
Interesting.
we are going to fall into this function, and it's going to add those numbers up, and we're going to get a 32 in here, and that's what we're going to return, and it is going to be saved in this variable. If we print it out, it's going to give us 32. I hope this makes sense. Let's go and run our program, run the task. Well, with GCC, the world is going to go fine. We're going to go back to our terminal here. Let's clear so that things don't disturb us and bring in some confusion. We're going to run our rooster program, and exactly what we had here, we have a 13 from the first statement here. We have a 7 from this statement here. We have a 20 from this sum here, which is here, and we have a 32 that we got from this function. The good thing about functions is that we can reuse them. Now that we know how to use it, we can use it again, and we can say sum equals add numbers, and we can say 30 and 54, for example. You add them up and you're going to get the result. So we're going to print the result sum, and we're going to put in the sum. I really want you to take some time and play with this statement so that these things make sense. It's really not that difficult, but you just have to wrap your brains around how C++ defines these things. So we have this statement, and we are adding 30 and 54, so we should get an 84 after the 32 here. Let's build. We're going to run the test build with GCC. We're going to click on the terminal here and hit enter. Let's clear so that we don't have things disturbing us, and we're going to run our program, and we have our trusty 84 here. I really hope this makes sense. And as a bonus, I'm going to show you that you can also call things in the std cout statement here without having to store them in some predefined variables. And sometimes this comes in handy. So you can say std cout, and we're going to say sum, and you might say add numbers right in here, and you're going to say 3, for example, and 42, and this is going to give us a 41. That's what we should expect to see after 84 here. So let's build and run the task build with GCC. The build is going to be successful. We click on the terminal here, we hit enter so that we see our terminal with output. We're going to clear so that we see our output without noise. We're going to run our program, and we're going to see a 45.
Got $1 billion web
Interesting.
turned it into reality and posted on Horizon.
I really hope this makes sense. The whole point of this lecture was to make you aware of statements and function. A statement is the most basic unit in your C++ program. It basically lives on one line, but it can also spread across different lines. But we're not going to look at that here. Maybe we're going to see that later in the course. Statements are executed in order, so when our main function gets to be run by the computer, it's going to go from first statement, second statement, third statement, and it's going to go until it hits the end. And we can see that here. in the order in which our numbers are printed, it is going from top to bottom. We have also seen that we can split our code in different functions and wrap whatever functionality we have in a function. We have seen the basic concepts of functions. A function has a return value, has a name, and you have to give it the parameters, and it puts the body of your function within these two curly braces. As an exercise, I would challenge you to do a function that multiplies two numbers and call it in the main function here to see the result. If you have any problem, please do ask me. I am going to do the best I can to help you out. This covers all we set out to do in this lecture, and I hope you found it interesting. We're going to stop here in this lecture. In the next one, we're going to see how we can input and output things from our C++ program. Go ahead and finish up here. Leave me there. In this lecture, we're going to learn about how we can get things in our program and get things out of our program. And that's basically input and output to and from our program. We have actually been doing this all along. We have been printing things from our program to the console. And with this technique, you can really think of stdc out as a highway that goes from your program to the terminal. You can basically think of it like this. Data is going from your program to stdc out, and it's going from here to the terminal. And from this, you might get an idea why these less than signs kind of point to the left. Because data is going from your program to stdc out, and these two symbols point to the left. They point to stdc out to signal to the fact that data is going from here to here. I really hope this makes sense, because sometimes these things can confuse people. This is the reason why it's going from your data to stdc out.
Oh, goodness. Oh my god.
Basically going from your program into HPDC out. And the HPDC out is one way we have to get data from our program to the console. There are many others. We have STDCERR or STD This is what I like to call it. And what it does, it prints errors to the console. We have STDC log, which is going to print.
See, this is interesting. Okay, hold on.
Discover things and get things out of our program. And that's basically input and output to and from our program. We have actually been doing this all along. We have been printing things from our program to the console. And with this technique, you can really think of HTTC out as a highway that goes from your program to the terminal. You can basically think of it like this. Data is going from your program to HTTC out, and it's going from here to the terminal. And from this, you might get an idea why these less than signs kind of point to the left. Because data is going from your program to HTTC out, and these two symbols point to the left. They point to HTTC out to signal to the fact that data is going from here to here. I really hope this makes sense, because sometimes this things can confuse people. This is the reason why it's going from your data to HTTC out. Data is basically going from your program into HTTC out. And the HTTC out is one way we have to get data from our program to the console. There are many others. We have STDCERR or STD This is what I like to call it. And what it does, it prints errors to the console. We have STDC log, which is going to print log messages. Why do we have these different things? Different programs might decide to format these messages differently because they are different messages. One is a simple message from the program, another is an error. You might want to turn this red to really bring the attention into things that confuse people. This is the reason why it's going from your data to HTTC out. Data is basically going from your program into HTTC out. And the HTTC out one way we have to get data from our program to the console. There are many others. We have STDCERR or STD.
Hmm.
This is what I like to call it. And what it does, it prints errors to the console. We have stdc log, which is going to print log messages. Why do we have these different things? Different programs might decide to format these messages differently because they are different messages. One is a simple message from the program, another is an error. You might want to turn this red to really bring the attention to this message because the user has resolved that problem. Another might be a log message that you want to store in some file or some database. Uses for these things differ, and C++ makes sure to give you different ways to state your intent through the tools that you use. We have looked at stdc out, stdc error, and stdc log. What does stdcin do? It does the reverse. It's going to take data out of the program and bring that into the program. So let's look at a few examples using these. Here we have an example of creating data from the program to the terminal through cout, cerr, and clog. Here we have a hello world message going to cout. Here we have a number going to cout. This is what we've been doing all along. We can also do a variable storing the age, for example. It's a whole number, it's an integer. So we print this out, and the message is going to go from the program to cout. So you can think that things are going from the program to HD.
Women's multivitamins are formulated to support women's overall health, so you never miss a beat. Another email? No big deal. A quick workout? Yes! Strength starts from within. Then it's apron on. You're making dinner with your little sous chef. You show up, and One A Day is here to support overall health, including immunity and energy. Shop today. One A Day. The one for you.
love same-day delivery with Shipt, but it's so much better since I signed up for Target's Circle 360. Why? Because I no longer pay price markups from the majority of stores through Shipt. Only a handful of alcohol retailers and items don't count. That means no markups on groceries, pet food, even home goods and makeup. So to recap, I have more time to catch up on life while someone shops for me, and I spend less. It's a win-win. Order now at shipt.com/360. Terms apply.
to see that, we can use CER to print errors to the terminal, and we might say something went wrong or something along these lines to bring the attention to the problem. And we can use CLog to print log messages, and they work the same way. They all use this output operator, and it is going to take data from the program to the output stream read. This is what we mean here. Here is an example of how we might read data and bring that into the program. Here we have two variables. One is the age. It's a whole number or an integer in C++, and the other is a string. This is the type that allows you to store strings in C++. We're going to learn a little more about this later, but here I want to use it to really make it clear that you can get things from the outside and bring that data in your program. So we're going to let the user type in the last name, and this statement here with CIN is getting data from the stream or from the highway through which data comes into our program and bringing that in our program. And here it should be clear that the flow of data is in this direction. Data is going from CIN and we're storing that in a variable that we have in our program that is called name. We do the same thing and ask the user to print the age, and they are going to print that, and the data is going to come from CIN, and we're going to store that in our age variable here. After we collect the data from the user, we're going to print that, and we're going to say hello, we're going to print the name, and we're going to say they are whatever years old. This is what this program does, and I really hope it makes it clear how data input works through strings in C++. Another thing we can do with stdcin is chaining input, and we can use this technique to grab data in one statement. Look at the program down here to really understand this. We have the semi-variables, age and name. We let the user type in the last name and age separated by spaces, and we grab the data. We first grab the name, after that we grab the age, and we're going to print the same things. And we can chain input stream operators like this to grab the data in one go. And this may come in handy sometimes. Before we try these things in Visual Studio Code, I want to bring your attention to a problem that you are likely to come in contact with, and that is reading data with spaces. What if the user types the name with spaces? For example, you ask me to type my name. I'm not going to type Daniel. I'm going to type Daniel Kakwaya, and your program is going to run into problems. C++ allows to solve this problem using std get line, and you use it using this syntax. You're going to pass in the stream where the data is going to go, and you're going to pass in the variable that is going to read the data, and you're going to have information stored correctly in your program. This might be not making sense yet to you. We're going to go to Visual Studio Code and play with this, and I am sure it is going to make sense. Okay, here we are in Visual Studio Code, and we have our project where we're going to store our files, data input and output.
Okay. Okay. Oops. Crap. 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 Oh no. Oh wait, we're good. Output. Okay. Here, you know what? Let me do something real quick, if I can.
Copy code from our template project, and we're going to
Okay. Let's see. Was the food good, mother? Was the food good? Good. I'm glad. 8.3. Errors and warnings. That is 3.4. Okay. 5. And then this will be 3.6. Alrighty. Oh, right. Well, no, well, it's not a big deal.
Put the data in, and I'm going to open this folder in Visual Studio Code. So let's close whatever we have now, and I am going to open my folder. Let's browse there. I am on this folder, data input and output. I am going to select that, and the project is going to open up in Visual Studio Code. I am going to jump to my main function. I am going to take out friends we don't need. And the first thing we're going to do is printing data. We have already done this, so we're going to practice this a little bit. We can say stdc out, and we're going to say hello C++20, why not? And we're going to put an stdendl at the end, and remember our semicolon. And here, I want you to really put in your head that data is going from our program here to stdc out, and stdc out is going to dump that on the terminal. That's how this works. You can also do a variable, let's say int age, for example, let's say 21, and end this with a semicolon. And we can also print the age. We can say stdc out, and we can say age. This is going to be sent to the output stream, and we're going to do stdendl to add a new line character at the end. And we can try to go to this before the program gets more complicated. Let's go to terminal. We're going to run the test world with GCC and age. This is going to be sent to the output stream. And we're going to do stdendl to add a new line character at the end. And we can try to go to that before the program gets more complicated. Let's go to terminal. We're going to run the test world with GCC. And if we hit enter on the terminal here, the terminal is going to go away. We're going to create a new one, no big deal.
Before I can use my mind.
And if we do dir, we're going to find our rooster program. If we run it, it's going to say hello C++20, and the age is going to be 21. We are taking that from our program and putting that to the terminal. This is pretty cool. And you can think of stdc out as the highway that is really going to take your data from your program and bring that to stdc out like this. We're also going to take the age. It's going to go through stdc out, and it's going to show up here. You can think of this like this. Okay, now that we have used stdc out, we can use stdc err and stdc log in the same way. So we're going to say stdc err, and we're going to say error message. And the message is going to be something is wrong. You may do whatever you want in here. And we have to remember to put a new line character, otherwise data is going to be cramped on one line. We can also use stdc log. It really works the same way, c log, and we can say log message, and we're going to say something like, and we remember to put stdendl in our semicolon. If we close this program, you might get what it's going to do. It's going to print these things on the terminal. But this might be useful to terminal programs that support features to format different messages directly. The program is going to know that one message is a simple message, the other is an error, the other is a log message. Let's run our program. But before we do that, let's clear so that we don't have noise here.
Hold on. What? Hold a minute.
but this might be useful to terminal programs that support features to format differently if something happens. And we remember to put std, endl, and our semicolon. If we build this program, you might guess what it's going to do. It's going to print these things on the terminal, but this might be useful to terminal programs that support features to format different messages directly. The program is going to know that one message is a simple message, the other is an error, the other is a log message. Let's run our program. But before we do that, let's clear so that we don't have noise here. We're going to run the program, and it's going to
Okay.
the error message and the log message here. Okay,
Okay,
now
good.
what we're going to look at is how we can get data into our program. And data is going to be going in a different direction. It's going to be coming from the terminal and flowing into our program.
Excuse me.
What we're going to do, we're going to do int h1. This is the new variable. So we're going to put in data. And we're going to bring in a string library to allow our program to store strings. The way we're going to do that, we're going to include string. This is how you do it in C++. We haven't really learned about this type. It's a powerful type in C++, but we will get there when we get more powerful tools to really understand it. We are just getting started here. So what we're going to do, we're going to say std string, and we're going to say name. And we're going to ask the user to print their name and age. You already know how to do that. So we're going to say, please type your name and age. And we're going to do std and endl on this. And how are we going to get data in the program? We're going to use stdcin. And we're going to do stdcin. And that is going to be going from the string to the program. So the string input operator here points to the right. And that is going to be going in the name variable because that's what they're going to be typing in first, because that's what we told them to do. So we're going to store the name, and we're going to say stdcin. That is going to be flowing from stdcin into our age1 variable.
You have so many edits to make.
Okay, now that the user has given us their information, we can greet them with a personalized method. We're going to say std_cout hello, and we're going to put out their name, and we're going to tell them you are, and we're going to put the age 1, because that's what they're going to give us here, and we're going to say years, and we're going to put an std_endl here. I'm going to grab this and pull this to the left so that we can see our entire program here. That's helpful. So what we are doing here, we are getting data from the user, and we are storing that in our variables, and we are creating the message so that the user can see it. I don't want the first thing we did here to disturb us when we build and try this out. So I am going to comment this out and comment the first block of code using block comments. I think this is the first time we use this. And
Okay, hold on. So you want me to do what? Okay, so anything here from the top. So that'd be slash apostrophe. And then it's the other way, or what? Apostrophe slash. There we go. Okay.
this is going to be ignored by the compiler now, and it is only going to consider this. And this is going to be pretty cool. Let's go down a little bit here and try to build the program. Going to run the task that builds with GCC.
Hold on. I did something wrong. Was it age 1? Oh, it was age 1. Okay, let's do that again. There we go. Oh, shit. Okay.
Looks like the work is good. We're going to hit enter and we're going to clear so that we are not disturbed by that. We're going to run the program. Let's say rooster.exe. It's going to ask me to type my name and age. My name is Daniel. I'm going to type that. Hit enter. It's going to want me to type my age. So I am going to say 33, for example. And it's going to tell me, hello, Daniel, you are 33 years old. I put a slash here. We can try and run it again so that I don't have to make that mistake again.
Interesting.
So Daniel, that's my name. I hit enter, say 33. And if I run, it's going to say, hello, Daniel, you are 33 years old. I hope this brings the point home that STDCIN is a highway that takes data from the terminal into your program. So this is really what is happening here. When it's going to flow from the terminal and it's going to go into my variable, which is named here. And when I type the age, it's going to go in my age variable here. And all this happening through stdcin here. Okay, one other thing we can do is grab the data and put that in our variables in one go. So what we can do here is comment this out, and we're going to do stdcin. We're going to put that in name, and we're going to change these two things and put the other piece of data. And we're going to do stdcin, and we're going to put that in name, and we're going to change these two things and put the other piece of data in H1. If you run the program, it's going to work exactly the same way, but we are grabbing the data in one line.
Make that 3. Repeat. Count 1. Save card. You were.
I see. I see, as opposed to being separate like this, these two.
So well, to see this in action, we're going to run the task that world with GCC. We're going to click here and we're going to clear. If you run Rooster, it's going to ask for the name and the age. I'm going to put in Daniel, and I'm going to put my age and say 33, for example. And it's going to do exactly the same thing, but we have one compact line. The last thing I want to show you in this lecture is how you can grab data with spaces. Because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear, and I'm going to run Rooster again, and I'm going to say Daniel. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So
wait, what?
Name, and it's going to fail. Last thing I want to show you in this lecture is how you can grab data with spaces, because if I try to put in data with spaces here, the program is going to fail miserably. Let me show you this. I'm going to clear, and I'm going to run Rooster again, and I'm going to say Daniel. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So C++ provides a way to solve this using std_get_line. So let's
hold on. So if you what?
A chance to input my age, and this is really bad. I'm going to put in my full name, and it's really not grabbing the second name, and it didn't give me a chance to input my age, and this is really bad. So C++ provides a way to solve this using std_get_line. So let's say what we are doing here. And before we play with this, we're going to comment out what we have here so that it doesn't disturb us in what we are about to do. So let's come down here and say that we were doing data input. This is helpful here. And we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I'm going to stdc out. So the way I'm going to grab the data, I'm going to do, and I'm going to go down and grab to disturb us in what we are about to do. So let's come down here and say that we were doing data input. This is
oh, golly, dude.
Helpful here, and we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I'm going to stdc out. So then I'm going to grab the data. I'm going to do std get line. You see that we have this function here, and it's going to take an input string. So stdcin is going to work, and the second parameter is going to be the variable where this string data is going to be stored. We're going to pass in our full name, and this is going to work just fine. And we're going to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age tree variable. Once we have the data, we can greet our user using the same method we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring this to the same location. It's going to be full name here, and it's going to say age 3. And let's try it. Well, going to terminal, run the test work with GCC, and we have a problem because we forgot our semicolon. See how these problems might come to you? So we're going to put in our semicolon, and another thing that we want you to see is that you can bring these things to the next line if they turn out too long, like you see here. So I can, for example, put this to the next line, and it is going to work just fine. So what I am going to do, I'm going to try and work.
Okay, hold on, Bob.
For age 3, to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age 3 variable. Once we have the data, we can greet our user using the same method we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring this to the same location. It's going to be full name here, and it's going to say age 3. And let's try. I'm going to terminal, run the test work with GCC. And we have a problem because we forgot our semicolon. See how these problems might come to you? So we're going to put in our semicolon. And another thing that we want you to see is that you can bring these things to the next line if they turn out too long, like we see here. So I can, for example, put this to the next line, and it is going to work just fine. So what I am going to do, I'm going to try and build again, run task to build with GCC. You see that the build is good. I'm going to bring in our terminal. I'm going to clear so that we don't have noise here. And we're going to run a program. It's going to ask me to put in my full name. And it's going to want the age. I'm going to say 33. And it's going to reach me, hello, Daniel Kaplaya, you are 33 years old. We are able to bring data with.
Oh no, it says I'm 1 years old, which is okay. What? See if I can figure this out. Years old. What?
To one clear so that we don't have noise here. And we're going to run. It's going to ask me to put in my full name. I'm going to say Daniel Kaplaya, and it's going to want the age. I'm going to say 33, and it's going to reach me. Hello, Daniel Kaplaya, you are 33 years old. We are able to bring data with spaces into our program. And this concludes what we had to say in this lecture.
Hold on.
It has Great data. Age will be the provides a way to solve this using std get line. So let's say what we are doing here. And before we play with this, we're going to this is helpful here. And we're going to go down and grab data with spaces. So I am going to set up another string, and this is going to store my full name. That's what I'm going to say here. And to grab it, I'm going to tell the user to type in their full name and age. So I'm going to stdc out. So the way I'm going to grab the data, I'm going to do std get line. You see that we have this function here, and it's going to take an input string. So stdcin is going to work. And the second parameter is going to be the variable where this string data is going to be stored. We're going to pass in our full name, and this is going to work just fine. And we're going to also grab the age using the same technique we've used before. So we're going to say stdcin, and we're going to store that in our age3 variable. Once we have the data, we can greet our user using the same message we had before. So I'm going to copy that, if I can do that, and I'm going to paste that here. I'm going to bring this to the same location. It's going to be full name here, and it's going to say age 3. And let's try in world. Going to terminal, run the task world with GCC, and we have a problem because we forgot our semicolon. See how these problems might come to you? So we're going to put in our semicolon, and another thing I really want you to see is that you can bring these things to the next line if they turn out too long, like we see here. So I can, for example, put this to the next line, and it is going to work just fine. So what I'm going to do, I'm going to try and world again, run task to world with GCC. You see that the world is good. We're going to bring in our terminal here so that we don't have noise here, and we're going to run a program. It's going to ask me to put in my full name. I'm going to say Daniel Gakwaya, and it's going to want the age. I'm going to say 33. It is going to reach me. Hello, Daniel Gakwaya, you are 33 years old. We are able to bring it together with
I need a poo.
With YouTube Music Premium, listen ad-free. Offline.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 40